the main point of this question is to really get across this idea of orientation of a parametric set of equations. In other words, where does t start? Where does our parameter start and where does it stop? And which direction does that imply as we work our way around the parametric curve? So to illustrate this point, I want to go over these two examples first. I want to do x equals cosine t, y equals sine t, and then we'll move on to the negative parameters of those. X equals cosine negative t, y equals sine of negative t. And we're going to start to see a pattern emerge, and we can start talking about these other problems too. Now, in the second half of this video, it won't take too long, but we're going to go over how to do this problem in the case of no graphs given to you. And that's really very straightforward. This should be like a 30-second conversation after we get the idea down in terms of the graphs. So, starting with the vanilla version, right? This is just cosine t, sine t. There is no shift in the parameter. There is no reorientation of the parameter. It's as simple as it can get. Now, the way I'm going to solve this is to remind us that t starts at 0. So let's say t equals 0. Well, that means x equals cosine of 0, which means 1. And y equals sine of 0, which equals 0. Okay, and what happens as you move to greater t values? Remember, t goes all the way up to 2 pi. If t were equal to pi over 2, for example, x equals cosine of pi over 2, which equals 0. And y equals sine of pi over 2, which equals 1. So that's the direction we're going in here. We're starting at x equals 1, y equals 0, and we're moving to x equals 0, y equals 1. And we'll have more values for all the values of t, right? 0, pi over 2, pi, 3 pi over 2. You could even pretend there's fractions in between, like pi over 4 or whatever. But we've got our first one right here. Okay, see, that's the direction implied by those equations. And then next, imagine if t is negative. So you plug in 0, it's still 0, right? So our starting point is still exactly the same place. But as t grows, instead of going pi over 2, pi, 3 pi over 2, it's doing the negative versions of those. So it's going to be a circle going in the opposite direction. Okay, and you can see the effect now of having a negative parameter. It reverses the orientation of your curve, whatever the curve is. And this is a simple circular shape, but if you had some crazy shape, if you flip the sign on t to be negative, all you're doing is you're changing the direction of that curve. Now, in terms of these shifts going on here, well, these aren't too hard to sort through. Let's take this one, pi over 2. Imagine I had t plus pi over 2 as my equation. Well, you plug in t equals 0, you're going to get cosine of pi over 2, which is a little further ahead than you expect it to be. So in other words, this is our starting point now when you have t plus pi over 2. Okay, and oops, I picked the wrong orientation. Got to pay attention. There's one of each. Here we go. Right here. It starts there, and it goes in this direction. Okay, negative t is the one I was looking at. Negative t plus pi over 2. That's going to be right here, but it goes in the reverse orientation. Okay, so that's what's implied by this problem. It's just simply getting your head around shifting the starting point and reversing the orientation. Now, in this next part, if this is the problem you're looking at, it's exactly the same thing that I just talked about. And in this particular case, I even put them in the same exact order. There's no variation in this example right here, because I just wanted to point out these are all counterclockwise, which means they're all positive t values. And these ones, which are clockwise, remember which way a clock goes, that's the reversed orientation where t is negative. And if you start at t equals 0, well, there's no shift right there. But if you move along and you say, okay, now how about t equals pi over 2? Well, now we've got a shift right here. Okay,